third quantum number is magnetic quantum number and its symbol is M. This quantum number mainly talks about the orbitals. See, we are knowing now, the first quantum number, principal quantum number, talks about the orbits. The second quantum number, azimuthal quantum number, talks about the suborbits. And the third quantum number, which is this one, the magnetic quantum number, talks about the orbitals. It says it is the number of orbitals in a subshell. Remember, it is the number of orbitals in a suborbit or a subshell, and it is equal to always twice of L plus 1. How many further divisions we have in any subshell or the suborbit? And this is always equal to twice of L plus 1. The second thing which it talks about is that it gives us the orientation of the orbitals in the three-dimensional system. In what all directions the orbitals are aligned, like whether they are in the x-axis or y-axis or x-axis. Or we can say it gives us the orientation of the movement of the electron in the three-dimensional system, because it is actually the electron which is moving in these orbitals. And third and the most important, that the magnetic quantum numbers value is always from the minus L to plus L. And that is why all negative values and all positive value makes it twice of L, and the 0 makes it 1. So this is how we have actual total M values twice of L plus 1. Now let us understand these three quantum numbers and their interpretations in a tabular form. Like we know N, it mainly talks about orbits. L, it talks about suborbits, and the M, which talks about orbitals. We know the value of L is 0 to n minus 1, and value of M is it's minus L to plus L. Now let us see the first orbit. In the first orbit, the value of L possible are only 1, which is 0, and when we know the value of L is 0, it is actually representing S subshell. Now this S subshell has how many further orbitals or divisions? If we see this, we can understand, and once the value of L is 0, M will also be 0. So S has no further divisions. So S in itself is an orbital as well as suborbit also. And in the box diagram, we represent it like this. Simply this S. We call it 1s. Then let us move to the second orbit. Second orbit will have how many values of L? 2. So it will have 0 and 1 from 0 to n minus 1. So how many subshells does it this second orbit is having, or suborbits? It's 2. Now we know when L is 0, it is representing S subshell, and when L is 1, it is representing P subshell. So we have two subshells in the second orbit, S and P. Now let us see how many further divisions they have of the orbitals. We know S, since value is 0, it will be 0. So the S suborbit is not further divided, and it in itself is an orbital also. But once this value of the L is 1, we can know the value of the M will be plus 1, 0 and minus 1, because its value is from minus L to plus L. So how many values does this when L is 1 is having? It's 3 values. How we can make out? It's twice of L plus 1. So twice of L plus 1 will make twice of 1 plus 1 is 3. So these are the 3 values. So it means what? The P suborbit is further divided into 3 orbitals. So these are, each individual box is your orbital. It is the path around the nucleus where the probability of finding the electron is maximum. Let us now move to the third orbit. The third orbit will have how many values of L possible? 3, 0, 1 and 2. We know 0 means S suborbit, 1 means P and 2 means D. We know its values will be only 0. In this case, it will be plus minus 1, 0. So S is not further divided, but we know P is divided into how many orbitals? 3. But one we know if L is 2, twice of L plus 1 will make it to have 5 values. It will be plus minus 2, plus minus 1 and 0. So total of what? How many values? 5. So we can now make out this D suborbit is further divided into how many orbitals? 5. So this 3D has how many divisions? 5 divisions. The fourth orbit will have how many values of L? 0, 1, 2 and 3. So it will be having 4 suborbits. Fourth orbit, 4 suborbits. Fifth orbit will have 5 suborbits. Sixth orbit will have 6 suborbits. So this is how we move. And this, when an L is 0, we know it is S suborbit, 1 P suborbit, 2 D suborbit, and 3 means F suborbit. How many values of M are possible in case of L is 0? It is 0. How many values of M are possible for L1? There are 3 values, plus, minus 1 and 0. How many values of M possible for L2? There are 5 values, plus, minus 2, plus, minus 1 and 0. And how many values of F now M possible in case we have F suborbit or L is equal to 3? There are 7 values, plus, minus 3, plus, minus 2, plus, minus 1 and 0. So all these are the 7 values. So it means what? I can draw here for you. It means the S suborbit is not further divided. It is orbital as well as suborbit in itself. P is divided into how many orbitals? 3. D is divided into how many? 5 orbitals. And remember, the F is divided into 7 orbitals. So this is, we call it, we say 4s, we will say this as 4p, we will say this as 4d, and we will say this as 4f. So this is how we have divisions of the orbits to suborbits and orbitals with the help of these 3 quantum numbers.